Hello, my name is Anita Owamera. I'm third year student of agricultural mechanization. I'm going to present about ergonomics in farm machinery. We can start from introduction. Ergonomics is the science of designing equipment to fit the human body and its cognitive ability. In farming, proper ergonomics reduce some disorders like muscle and manage the stress and maximize the productivity through better machine interface. You can start from control panel design. Through designing, we must design in effective way with logical clusters by coding, by priority, emergent stops in highly accessible zones. For this, we replace mechanical levers with programmable controllers to improve the intuitiveness and reduce fatigue by mapping tactile feedback and mode clarity by avoiding mode confusion in complex tasks. For GPS interference design, we ensure the precision of agriculture, support efficient data processing without distraction by readability on high contrast of direct sunlight, simplicity. Of course, design must be simplicity, readability, and shallow manners by preventing eye of field time. For alarm effectiveness, as you see in this figure, they show that the graded alarm, the table shows everything you can need while operating the tractor or other machines like cars and multimodal by visual flashing and set vibration and clarity for specific instruction rather than vague pings. We can go on cabin layout and efficiency. Here, optimize the spatial relationship between seat, console, and pedals for total operator comfort. Hand will design the what and how the operator will be sit and feel comfortable, not feeling fatigue or muscle problems by clearing storage, and we can design for follow by minimizing body twisting during the operation. As you know, our field is not the flat field, it is maybe it can be on inclined soil or muddy soil. For combined harvester reach, the defining zone for control accessibility to minimize the risk of operator injury. For this topic, you must design or a machine for combined harvester by minimizing the how operator can meet the injury. Sorry, we can continue for understanding more for this point of 6. can design for steering header, or second reason for radio AC must feel comfortable, must feel the, the good things while operating. For tertiary reason, we, we must focus on phases or deep setting. We can go on the point 7, which is foot control design. While designing the machine or tractor, the designer or engineer must focus on the pedals for heavy works, boot capability, and fatigue reduction by spacing how it will be in the size, by preventing the accidental dual press and surface on steep aggressive tread, and on force for balanced actuation to prevent leg strain. About hydraulic system ergonomics, moving from high force mechanical levers to precision electronic control. Here, for design, we know that on the tractor we apply the implement. That implement may use hydraulic system. So while designing, sorry we must sorry we must focus on electronic hydraulic sensors, muscle usage for shifting load to shoulders or back, or fine-tuned implement movement. On the public road transport, while operating the tractor or other machine, managing the safety transition from high solid soil to high-speed public infrastructure, we may focus on large wide-angle mirrors in order to be focused well or watching very well the road, integrated lighting to turn the signals and hazard by avoiding the accident during operating the tractor on the road. Another thing we can focus on is road modes with stiffer suspension for pavement. On the autonomous farm machinery, can use the adapting operator role from active driver to system supervisor. Vigilance by keeping human alert during automation, by trust and transparent system thinking displays and showing how and where you are, and handoff seamless transition to manual control. All of these are for building machine or tractor which is comfortable to the operators and the nearby person, and by making the good practice whole body vibration. This is mitigating long-term spinal damage caused by heavy machinery movement. This we must focus on suspension seat, where the air damping technology must be applied to avoid the uncomfortable things for operator. Curb isolation for floating cabin mounts where you can lift up the chair or lift down the chair by comforting zone. The tire trays or radial tires for absorption. On the seat design or posture, we must maintaining the spine natural shape or S shape during long agricultural shift by rubber support, inflatable airbags for back serve in order to avoid the operator during operating the land unwanted movement for dynamic seating by rocking for micro movements and adjustability to to adjust the weight and height and the tilt turning while operating while operating the truck. For noise exposure mitigation, we protect hearing against engines, gearbox, and crop sounds. These help an operator to always feel comfortable in the avoiding the noise that can be interacted to him by minimizing sound leaks, integrating noise cancelling PPE, and cab flow for and holding dampening. Can continue on climate and performance, and you must design in how in each climate whether it is hot or it is cold, operator will always feel comfortable. When it is hot, we must design the way and how he will feel and he will feel comfortable for applying the air conditioners in the where he sits. For heat stress management, there is some advanced strategies for open station vehicles and AC failure scenarios. We design some jackets, bags, or hands where the operator will feel comfortable, like cooling vest, hydration access, and job rotation by limiting direct sun exposures. Long-term dust exposures. This preventing hardware failure and usability degradation due to agricultural dust by seaward gaps for cleaning and static coating and easy change intake systems. In day and night work lighting, by solving this problem, the depth perception and night blindness issues during 24 hours, we eliminating a deep shadow by reducing eye strain, and for spectral quality mimicking natural daylight. Rain and muddy conditions. The safety maintenance operation in slippery and low visibility environment, we apply the aggressive fluid, full grasses, whippers, and grip placement for ergonomic handhold for wet hands in order to avoid some accidents. Uneven terrain challenges. Reducing muscle bracing and fatigue caused by side slope and rough terrains. Here we use curb leveling, armrest support, or suspension turning by adaptive damping for bumps or bracing the torso effectively. On visibility and the blind spots. Here we're designing the motion geometry to eliminate critical visual abstraction by sloping hoods in order to perform the better forward ground insights and lower grasses door by seeing nearby ground hazards. Apply camera for 360 by degree monitoring on the screen. The way where the operator will see clearly and will perform well and will avoid the accidents. The tractor rover prevention. This diagram shows how it rotates or how the operator can see that there is braking control and ropes and stability feed and insuitable safety for confidence control placement. Here we see that the tractor is designed in the way it have high height, and we designed the 3 point of contact for safe ingress and egress by step spacing between 4 and 50 cm for human stride, for vertical grips on solid handhold alignment, and anti-slip coating for grit treated tread plates. This helps the operator to reach on in the tractor in easy way. For small-scale tool risks, here we address the ergonomic risks in manual looks like throw and legs. We use this for long handles, materials, wrist neutrality by reducing lumbar bending, a lightweight composites, and curved handle geometry. For muscular disorders, we designed the in ergonomic design. We prevent the chronic condition like sciatica and carpal tunnel syndrome by designing the comfortable things or something which is special which will prevent that problems by seats and control scenery. This will help the person to prevent that problem. On the design of hoes and sickles, we apply biochemical curves to traditional cutting and weeding tools. For swinging motion, the handle alignment for power is applied, and by Spine health. The angled grips for upright reading is applied in order to prevent and to meet the desired length is designed for the plowing. The ulnar deviation by reducing wrist strain. For traditional tool material, we upgrading the grandfather's tool with the modern energy absorption materials by reducing the impact to arms, lowering the perceived weight, and ergonomic elastomer curves. This helps to reduce some problems for people. We can continue on sitting with standing. We know that our soil is not on the flat part. It is different. Some are inclined, some are muddy. For sitting, it is better while driving, and for standing, it may lead for fatigue matters. And what you want is to avoid that problem for that fatigue. And for integration and comfort, here we solve the conflict between bike safety gear and the machine operation by extra space for heavy suites, a high-tech safety fabrics, and articulated PPE joints. On the metal workload management, on this, we prevent the analysis paralysis caused by excessive precision data by task-specific displays, offloading complex math, and prioritizing mission-critical alerts. On fatigue monitoring, we design how the operator will sit in upright, where he will not feel some problems while operating by using sensor technology to detect slowed reaction and micro slips. Ergonomics smartphone apps. These are designed for leveraging mobile technology for worker coaching and sensor telemetry for observing where the operator or machine is fine and operator is in compatible zone, and this is designed, it can be on phone accelerometer usage, hazard and near miss lodging, and lifting technique reminders. For smallholders with large scale, adopting ergonomic solution based on operational size and technology level. For smallholders, we use low cost to redesign. We design for the capacity of the holders. For large scale, the cab suspension and automation must be on the level where it is in normal. For heat focus, it is critical in manual systems. On the anthropometric considerations, the designing for measurement of the target individuals, not global. While designing, we design based on the individuals, the capacity of the individuals, where the fitting or global diversity fitting will be on 5 or 6 feet and operators by covering 5 to 95%. It will depend on the individual operator will use that tractor. Adjustable machinery design. By providing physical flexibility to accommodate diverse body size effectively, we see the three things, which are steering, seat slide, and pedal clusters for adjustable spacing where it is possible. By steering, we see on telescope and tilt mechanism. The gender sensitive design. We know that long time ago, women were not allowed to do many things. They were obligated to do homeworks. But as the development is increasing, we found that the women must work as the same for the men. For designing in ergonomics, we design by breaking the historical bias for machine designed by purely for the male physique. We design for on the women for the strength, stature, and belts, where we reduce force for hydraulics, lower steps, height for ingress, and anchor point for female anatomy. For challenges for elderly farmers, we design for reduced flexibility, version, and reaction times in aging population. We design a tractor or machine based on the age or the power or forces and who will use that tractor. For the display fonts must be larger and high contrast text in order in the way that when the aged person is going to use that tractor will see clearly on the board. For behavioral adaptation, we study how operators bypass bad design and creating safer alternatives by identifying slow use of safety guards, slouching due to poor test, integrating safety into workflow. This will help him or her to to be comfort and avoiding the problems while designing or while operating the tractor. The role of ergonomics in training. It bridges gap between machinery engineering and safe field operation. This will help him to design based on the engineering machinery and what he saw or learned on the field by correct suspension turning, safe kinetic lifting techniques, and early detection of physical fatigue. Ergonomics and productivity. The economic justification: comfortable operators work longer and more accurately because the designer designed the right things in the right way, where the problems are protected and avoided during the designing. The operator protected well and the machine are designed in the way that it is on the right base where it will meet the requirement of the land. On the machinery mechanical maintenance access, the design for maintenance prevent awkward posture during uptakes. When the oiling checkpoint in one location, it is checked where filter access from standing, a greasing point marked yellow. You know what to do because you know what you can do for machinery maintenance by avoiding the problem before it occurs. Impact of the PPE on stress. Here the analyzing how safety gear introduces thermal and mobility stressors. For thermal, the trapped heat and evaporation. Here we design how it will be protected. For mobility, these stiff layers restricting elbows. We design the masks or clothes which is comfortable for stress. High risk and availability. This the managing wide implement feasibility in high-speed public traffic. On this, the operator is we can go on the last point, which is called road transition ergonomics. Here we reduce the cognition stress during transition from field to high speed pavement by transportation button. This for it is single touch holding sequences. On the vibration shift, it is for the filtering tarmac frequencies. On the steering ratio, the variable response for road speeds. On the summary of our presentation, before I go on conclusion, Here it is the key takeaway we can take home. The first one is physical strain mitigation. This is for the transitioning from high forces mechanical control to low effort system like electronic joystick, optimized pedal zones, and micro adjustable seating that prevent chronic musculoskeletal disorders. The second one, it is the environmental isolation. This it is enclosed tractor cabins must use robust air filtration to block toxic dust, pesticides, and level dynamic suspension system to actively buffer the operator from dangerous whole body vibration caused by low uneven terrain. The third one is cognitive load reduction. This is the Designing Institute control layout through clear color coding examples like hydraulic lines and high contrast dimmable nighttime displays minimizes driver confusions, prevents accidental implement deployment, and combat mental fatigue during long shifts. The last one is public infrastructure safety. It is for moving heavy or specialized machinery between fields, introducing severe roadway risks, utilizing the standard visual alerts like a high reflectivity, low moving vehicle triangle to protect the operator from high-speed rear-end collision with public traffic. Ultimately, while we optimize the physical and visual relationship between farmer and the tractor, we minimize human error, maximize field efficiency, and exposure that ensure that the agricultural mechanization remains sustainable for the people who feed the world. I can conclude that ergonomic excellence, not luxury, but it is fundamental requirement for future of global food production. By prioritizing the human operator, we ensure safer, healthier, and more profitable agricultural industry. Thank you for your listening. I appreciate your time. Thank you. Another thing I can add on this presentation, it is the reference where you can find the more information about the design of ergonomics. Remember to share, subscribe, and comment. Bye.